It is a pleasure to welcome you to the pitch sharing session of the third edition of the lecture series on advancements in geotechnical engineering, from research to practice. At the pitch sharing session we asked the participants to explain their research with 3 slides and within 5 minutes. They were judged by a 4-member judging panel and the audience members. The pitches that were adjudged as top 3 by the judges and audience members are being shared. The following presentation was ranked second by the audience members.
Good afternoon, ladies and gentlemen. Today I will present my research entitled Bio-mediated soil improvement of loose sand with fungi. I'm Aswin Lim. I'm from Parahyangan Catholic University, Indonesia. The idea of this research came from the process of making tempe, an authentic Indonesian culinary. This one, the soybeans are bounded each other by the fungi, namely Rhizopus oligosporus. As we can see here, the brown color is the soybean and the white color is the fungi. How we eat this tempeh, we just simply deep fry it and it's very delicious. Then I try to mix this fungi or this tempeh inoculum into the loose sand and then spray it with the water content around 5% and cast it in the mold, cylindrical mold, the triaxial cylindrical mold, and then wait for the 3 days in the room temperature. And when I open it, we can see that, yes, the fungi is grow entirely covering the soil particles. And then what's going on here? I try another sample, like a direct shear sample. I tried to shear it and I found that the treated sand can have the cohesion increase about 24 kPa. In here, we can hypothesize that seems that the fungi can tie or bond the soil particles. And then I take the sample, go to the laboratory and do the SEM imaging, and also using the digital microscope. From the SEM point of view, we can clearly see that the mycelium of the fungi can bond, cover all the sand particles, and the hyphae can perform like a rope and tie each sand particles. From the digital microscope point of view, we can see a lot of white color, white cartons. It's the fungi, it's the mycelium. So why this topic is become important, I can say that from right now, this is the new field for investigation. I believe still few scholars are working on this topic. The second one is, it seems also that this technique is a low carbon technique for soil improvement. And the most important one is a relatively cheap and no need advanced technology. Everyone I can give you the tempeh inoculum, you just spray it to your soil, you give it water and it will grow. Okay, this is I think that this is a very cheap and no need advanced technology. And then how it is going to change the world? Frankly speaking, until today, I have no clearly idea how this research or this technology can change the world because it's still preliminary research. But I believe this topic will contribute to a greener construction. What I can say right now is the potential application, such as it may reducing surface erosion, it can maintaining slope stability under different climatic conditions, or it may become an impermeable soil cover, as we noticed that the fungi is very impermeable. The water is very hard to penetrate. It seems that by visual. So, what is the future challenge of this topic? First, I would say that the durability, and then another thing that's worth to investigate is how this technology, the soil and the fungi interact each other and we can investigate the effect of the water flow, the confining pressure, and the soil composition if we mix it with the silt or whatever soil. And the most interesting one, I guess, is we can use another type of fungi. I believe in this work, we have a lot of type of fungi and it can be used as a soil improvement. I think that's all for my presentation. Thank you for listening.